Hi student, welcome to chemistry class. In today's class, we are going to be looking at chemical combination. One of the objectives of our class today are one, to define chemical combination and bonding, to state different types of bonds that we have, state their properties, and how they affect various chemical reactions. On that note, let me define chemical combination. Chemical combination is, simply put, atoms of elements combining together to form compound. It shows us how these atoms combine together in order to form compounds, and of course the bond that exists between these compounds. Chemical combination, of course, translates into bonding in such a way that all compounds have bonds that joins them together chemically. Of course, do not forget that we've said that compounds are atoms of different elements that are chemically joined together. So in today's class, we want to look at the bonds that exist between these compounds and how they are formed. So I will start with the number one bond that we all know, and that is the ionic bond. Ionic bond. This is also called electrovalent bond. Now, electrovalent bond or ionic bonding are formed as a result of transfer of electrons between metals and non-metals, or between electropositive ion and electronegative ion. Um, when we say transfer of electrons now, let's take for instance in the compound sodium chloride. In the compound sodium chloride, we have sodium and chlorine. Sodium and chlorine. Now, I will show you how this bond is formed. For us to know how this bond is formed, we have to look at the electronic configuration of sodium and chlorine. These are the two atoms in this compound. Now, before combination, you have sodium and chlorine. So the electronic configuration of sodium is 281, while the electronic configuration of chlorine is 287. Remember, sodium has an atomic number of 11, while chlorine has an atomic number of what? 17. Now, sodium is having a valence electron of 1, while chlorine is having a valence electron of 7. In order to establish a stable octet structure, of course, note that the goal of chemical combination is that both atoms of the compound can become stable, and they reach stability by either attaining an octet structure of the noble gas or a duplex structure of helium gases. So in order to attain octet structure, sodium will lose one electron. We transfer this one electron to what? To chlorine, so that it can become 28 and chlorine become 287. Now let's show by means of diagram how this is being done. Now we are putting it here because we want to transfer the electron to this place. Now we have that of chlorine 2, 8, and then we have 7. Now this is the electronic configuration. So as I've said, for electrovalent bonding, sodium transfer the electron here so that it can become, so after that combination now, you have sodium becoming 2, 8, and this is how we draw the 2, 8 now. So you have it like this, and then chlorine becoming 2, 8, 8. 2, 8, 8. Now you can see that um, they are now stable because they have their valence electron has become 2 8 has become 8 and 8 respectively. So the compound is now stable, but as a result of the transfer of electron that is taking place, sodium becomes an ion. So you have sodium ion, while of course chlorine become a negative ion. This plus shows that sodium has lose one electron and chlorine has gained one electron, and that is why we call them ionic bond, because by transfer of electron the atom becomes an ion. So the bond that exists between these two is called ionic bond. Of course this is quite applicable in quite a number of ways. Number one, and that of course that takes us to the properties of electrovalent compounds or bond. But one of the properties is the ability to conduct electricity. Now, ionic compounds can conduct electricity because of the mobile electrons. We observe that electrons are being transferred from the electropositive to the electronegative. So as a result, there is mobile electrons. The electrons are moving, and electrical conductivity is as a result of movement of electrons. So ionic compounds can conduct electricity as a result of what? Mobility of the electron. Now another property is that all ionic compounds are soluble in water or any other polar solvent. Now as of course is one of the due to as a result of the bond that exists between them, they are soluble in water and polar substances, but insoluble in non-polar solvent like ether, benzene, toluene, etc. Again, they have high melting and boiling point due to strong intermolecular forces that exist between their molecules. So these are properties of ionic bonds, and of course we have explained what makes them up. Now we go to another bond that is called covalent bond. Covalent bond. So you can repeat after me by saying covalent bond. Now, covalent bond are formed as a result of sharing of electrons. In ionic bond, we said there is transfer of electrons, but in covalent bond, there is what? Sharing of electrons. So covalent bond are bonds formed as a result of sharing of electrons. Now this covalent bond can now be subdivided into pure or ordinary covalent bond, and then of course coordinate covalent, coordinate or dative bond. Now what do we mean when we say pure or ordinary? In pure or ordinary now, you have A wants to bond with B, A bonding with B. Both of them have electrons. Let's put it this way: both of them have electrons, and then they donate their electrons for sharing. So you can have A, B. So, but in pure ordinary bond now, they are forming. Both of them are donating electron for sharing. And again, this pure or covalent, pure ordinary, is subdivided into two, which are homonuclear and heteronuclear. Now, in homonuclear bonding, you have atom of the same element. The same element, they are bonded together. An example is when you have hydrogen atom bonded together, when you have chlorine atom bonded together, when you have oxygen atom bonded together, then when you have nitrogen atom bonding together. Now, an example of heteronuclear is HCl, H2O, NH3. Now you will see here that the compound that we have in it, they are made up of what? Different atoms of different elements. So you have atoms of different elements making up hetero. From the word hetero means two. That means that you have atoms of different elements combining together to form the compound. But in homonuclear, you have atoms of the same element combining together. So by means of Lewis dot diagram, we are going to be showing how these bonds are formed. Now, let's look at how hydrogen is formed. Now, hydrogen molecule has two atoms, which is hydrogen atom and another hydrogen atom. Now, recall that hydrogen is having one valence electron in its shell. So you have this valence electron, and this one is also having one. Now they will donate the two electrons. Each of them donates the two electrons. They share it between them so that they can form H. Now, two electrons make a bond. Two electrons make a bond, and that is why you're having these two electrons having a single bond here. So this signifies that an hydrogen molecule has a single bond that joins them to a single covalent bond, joining them together. Another example for this Lewis dot diagram is chlorine. Don't forget, we are giving an example. Another example is chlorine. Chlorine is having 7 valence electron in its shell. So you have chlorine. We have chlorine. We have chlorine. Then you have these two electrons will be shared. So this chlorine atom donates one electron. This chlorine atom also donates one electron. So you have something like this. So you have Cl. Please also note that there is something that is called bond pair and shared pair. Now for bond pair, the electrons that are used to bond together are called bond pair. Now we also have what is called lone pair. The electrons that are remaining after bonding has taken place is called lone pairs of electrons. So from here, a chlorine atom after bonding still have 1, 2, and 3. 3 lone pairs of electron on its atom after bonding. The same was equal. So it's using 1 to bond and 3 are remaining as lone pairs of what? Electrons. So generally, chlorine has a chlorine molecule has a single covalent bond. A single covalent bond. Now let's talk about another one. We have oxygen. Now the structure of the Lewis dot diagram of oxygen is 2, 2, and 2, and then you also have another one here, 2, 2, and 2. So when they bond together, this one will donate 2, this one will also donate 2. So you have something like this: 3, 4, 1, 2, 1, 2, and then it gives us O double bond. So after bonding, you have oxygen double bond. So an oxygen molecule is having a double covalent bond, and each of the atom is having 2 lone pairs of electrons remaining on them. Okay, now another example is nitrogen. So nitrogen is written in Lewis dot like this. Now when they bond together, each of the atom drops 3 electrons each. So you have this 1, 2, 3, 1, 2, 3. Then you have this. Then you have 1, 2, 3. Now signifying that a nitrogen molecule has a triple covalent bond. A nitrogen molecule has a triple covalent bond in a structure, and of course each of the atom after bonding has one lone pair of electrons each on them. So in the next lesson, we will look at heteronuclear covalent bonding. We will also look at coordinate covalent bonding. We will look at metallic bond, Van der Waals forces. Under Van der Waals, we have London dispersion force and dipole-dipole moment. And we also look at hydrogen bonding. Thank you, and God bless you.